Hi, I've had some students ask about IP addressing, specifically looking at a specific network and figuring out what the network address is, what the broadcast address would be, and then finding the range for the addressable end devices. And to be able to do this exercise, we need to understand the IP addressing structure, and we'll start with IPv4, which is a structure where we represent devices using 32 binary bits. But since we human beings are not really great at remembering 32 binary bits, the structure that has been commonly used is one called dotted decimal. And this is where the 32 bits are broken up into 4 8-bit sections, and each of those 8 bits is converted to a decimal number, and we human beings remember things like 192.168.10.1 or 172.60.32.10. Those things stick in our mind more readily, and that's what we use for determining the addresses when we configure routers or configure the NIC on a laptop or PC. But, hey, we're still in a world where the computer remembers binary. So we have to get some skill at converting back and forth. So here is an example where we have the number 209. How would we convert that into its 8-bit binary form? Well, we start by making a little chart with the bit positions. And since it's binary, we're looking at place values or columns, which are powers of 2. 2 to the 0, 2 to the first, 2 to the second, etc. Well, we can just write those as 1, 2, 4, 8, 16, 32, 64, and 128 for the 8-bit positions. So we take our decimal number, and starting from the left, we can say, is the number we're trying to represent larger than that largest bit position? In this case, it is. We would write a 1 in that bit position, which means we've consumed 128 of the value of the original number, which means we have to subtract 128 from 209, leaving 81. Now we can move to the next position. Is 81 larger than 64? Yes, it is. We can do a 1 in that placeholder as well. And now we need to have to take away the 64 from the 81, leaving 17. Is 17 greater than 32? No, it isn't. That would result in a 0 in that position. And we just move on. 17 greater than 16? Yes, it is. A 1 in the position, exhausting 16 of the value. 17 minus 16 is 1. And you can see we can now skip quickly 0, 0, 0, 1. That is the basic process for converting the decimal to the binary. Within address ranges in this IPv4 addressing scheme, we're basically concerned about 3 types of addresses: the network address, the broadcast, and the individual host addresses. The network address is what it sounds like. It's the address by which we name the network. The broadcast address is a special address used to inform the router that we'd like to talk to all the hosts in the subnet. And then, of course, each addressable device in our subnet is assigned a host address. So here's an example in what we call the /24 world. And what does that mean? Well, of the 32 total bits, 3 sets of 8, or 24 bits, are used to represent the naming of the network, and the final 8 are used to refer to the individual end devices or hosts. The network address is defined as that number or value where all the host bits are 0. So in this case, the last 8. The broadcast address is a special address where all the host bits are set to 1. And then every number that we count forward, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, all counting up in between would be our available host addresses. Here is an example that is not in the /24 world, but in a case where we've moved that dividing line further to the right. This is a technique to handle different sized networks. We don't always need 200 and some odd end device addresses. That might be very wasteful. So a technique is used to move that sort of virtual dividing line from the dot position to the right or to the left. In this particular case, we have a network that's called a /28. So we move from 24, 25, 26, 27 over to 28, leaving only 4 bits to represent our individual end devices. If those 4 bits are all 0, that is the name of the network itself. So that is this address here. If all those last 4 bits are 1s, that represents the broadcast address. And then everything that we can count between those two are our available host addresses. And you can see right off, this is why we have to start getting good at being able to convert between binary and decimal then decimal back to binary. Let's look at 1 or 2 examples for practice. So here we have a random address, 172.140.88.12 in what we call the /27 notation. And we are asked to find the network address, the broadcast address, and then the first and last usable host address. We can achieve this by using a charting method. So I sometimes just use a grid like this. And we saw that that address that we were given was 172.140.88.12, and it was in a /27. So I'm going to use my dividing line here and put it where /27 would be. Okay, so that will help me to visualize what is the network address, all the ones to the left of the blue line, and all the host addressable bits to the right of the blue line. So the network itself would be all the host bits being set to 0. Okay. And the broadcast address would be all of those host bits set to 1. Okay. Now, it is somewhat important to go back and look at that address we were given, which is 172.140.88.12, and figure out where that is in our scheme of things. And in fact, that number 12 in the final octet that we call it can be written this way, I believe. We'll double check this once we get it. So we have 2 to the 0 or 1, 2, 4, 8. Okay, so that should be 0, and that should be 1. Okay, so 8 plus 4 is 12, and that would be the binary notation for that last octet of .12. Okay, so this is the network address. That's the broadcast address. Somewhere in the middle of that range is the address that we were given in the problem. So we can see that these leading bits were all 0. So we can now convince ourselves that that network part would stay the same. And the first host address then would be all zeros starting at 1, right? And we could keep on counting through, but we have to end at 1, 1, 1, 1, 1. So what is the last number before 1, 1, 1, 1, 1? That would be 0. Whoops. Started in the wrong place here. 0, 0, 0, 1, 1, 1, 1, and 0. Okay. So our network address will then be represented by 172.140.88.0. That's what that is. Our broadcast address would be 172.140.88. Whatever the decimal representation of this much is, which happens to be 31, because we got 1, 2, 4, 8, 16, right, for the bit position. So that'd be 16 plus 8 plus 4 plus 2 plus 1 is 31. Network address 0, broadcast address 31, and the addressable hosts are then everything greater than 0, but strictly less than that 31.